A woman in New York holds up her phone and video calls her mother in Tokyo. She waves. Her mother waves back a half-second later. It feels like the words fly up into the sky, bounce off a satellite, and drop down over Japan. They do not. Those words dive straight down to the bottom of the Pacific Ocean, race through a cable no thicker than a garden hose, and travel 4 kilometers below the surface in total darkness, past shipwrecks and sharks, before they ever reach Tokyo. No signal from space carried that wave. A thread of glass on the mud did. Almost everyone thinks the internet is wireless and lives in space. It does not. Satellites handle a tiny sliver of the traffic. If every satellite in orbit vanished tomorrow, your Netflix would barely notice. But if a few cables on the seafloor got cut, whole countries would go dark. This is not a hypothetical. In 2008, cables in the Mediterranean were damaged near Alexandria, and connectivity in Egypt, India, and the Middle East collapsed at the same time. Tens of millions of people lost service in a single afternoon. Egypt lost about 70% of its connection. India lost around 60%, all from a couple of broken lines on the seabed. That is the real fragility hiding under the ocean, and it is why understanding these cables matters more than understanding any satellite. Here is the one idea that holds this whole video together. The internet is not a cloud in the sky. It is a physical map of glass threads lying on the ocean floor. About 1.4 million kilometers of undersea cable carry over 95% of all intercontinental internet traffic. Let that number sink in. 95%. Every email, every video call, every stream that crosses an ocean is almost certainly riding a cable, not a satellite. There are around 500 of these cable systems in the world, and together they stitch every continent except Antarctica into one network. Every message you send across an ocean is a pulse of light traveling through glass, not a signal beamed through the air. The internet is wired, and most of that wire is wet. So how does a wave from New York actually reach a hand in Tokyo? Let me walk you through it, step by step. Your video call leaves your phone and races over local wires to a coastal building called a landing station. This is a plain, boring facility on the edge of the sea. From the outside, it looks like a small warehouse. Nobody driving past would guess that half the internet for a whole region passes through it. It is the doorway where the land internet meets the ocean internet. At the landing station, your data enters a submarine cable and turns into pulses of light. Inside that cable sit hair-thin strands of glass called optical fibers. Each strand is thinner than a human hair, yet it is astonishingly clear. Your words are now flashes of laser light, blinking on and off billions of times a second, sprinting through that glass at nearly the speed of light. The cable dives off the continental shelf and drops to the deep seafloor, often 4 kilometers down. That is deeper than most submarines can ever go. Out here the cable is thin, only about 17 millimeters across, roughly the width of a garden hose. It is not armored at all. Down here there is nothing to hurt it. No anchors, no trawlers, just cold water and darkness. So it just lies in the dark on the mud, mile after mile. Light naturally fades as it travels, so the cable cannot run forever on its own. Every 50 to 100 kilometers there is a repeater, a small booster that grabs the weakening light and shoves it forward again. Without them, the signal would die long before it crossed the ocean. A single trans-Pacific cable can hold hundreds of these boosters lined up across the whole seafloor, each one powered by electricity sent down the cable from land. Near the shore on the other side, the danger goes up, so the cable gets thick. Close to land, engineers wrap it in layers of steel wire and sometimes bury it right under the seabed. A cable that was garden hose thin in the deep can end up as thick as your arm near the coast. This is where ship anchors and fishing trawlers do most of the damage, not the deep middle. The light finally climbs back up to a landing station in Japan, turns back into normal data, and shoots over local wires to a phone in Tokyo. The whole trip across the Pacific, thousands of kilometers, takes a fraction of a second. 6 steps, 1 ocean, and a wave that felt like magic was really glass and light the entire time. Let me make this real with one number and one strange fact. A single modern cable, like the ones Google and Meta help fund, can carry hundreds of terabits of data every second. Google's Grace Hopper cable, for example, moves around 350 terabits per second. That is enough to stream tens of millions of high-definition movies at the same moment, through one hose-thin line on the seafloor. Now the strange part. For years, people blamed sharks for biting cables, and knocking out service. It really happened. Back in the 1980s, sharks off the Canary Islands chewed through cables and short-circuited them. Sharks are drawn to the faint electric fields around the cables, and companies started wrapping them in tough, shark-proof material. But here's the twist. Sharks cause almost none of the real damage. Fish and sharks together account for less than 1% of faults. The true villains are ship anchors and fishing gear near the coast, which cause most of the more than 150 cable faults repaired every year around the world. When a fault happens, a specialized cable repair ship sails out to the exact spot, drags a hook along the seafloor, physically lifts the broken cable up to the deck, splices it back together by hand, and lowers it back down into the deep. There are only a few dozen of these repair ships in the whole world, and the whole job can take days or even weeks. In the 21st century, we still fix the internet with a boat and a fishing hook. So remember this. The internet is not in the sky. It is a fragile web of glass threads lying on the ocean floor, and almost all of it fits inside cables no thicker than a garden hose. The next time your call crosses an ocean, picture that light racing through the dark for kilometers down. Subscribe to Tech with Joel for the wild but true wiring behind the tech you use every day, explained fast. Quick question for you. Did you honestly believe most of the internet went through satellites before today? Tell me in the comments. Next long form, I break down the hidden buildings called data centers, the giant, humming warehouses where the internet actually lives when it is not swimming across an ocean. Subscribe to Tech with Joel.